opportunities. Today we will continue this session with our exciting journey with yet another power-packed lineup of sessions, distinguished speakers, and interactive engagements that promise to push our understanding of cutting-edge technology even further. With no further delay, I will like to introduce our chief speaker today, Dr. Pradeep Kundu sir. Dr. Kundu is an assistant professor at Bruges campus of KU Leuven and is a key member of Leuven AI, the university's Artificial Intelligence Institute. He leads pioneering research in industrial AI and digital twin technologies, focusing on predictive maintenance, fault diagnoses, and intelligent manufacturing systems. His work is shaping the future of AI 4.0, bringing together the advanced AI, machine learning, and engineering to make our industry smarter and safer. First of all, I would like our principal of SRIT, Dr. Sailesh Gupta sir, to welcome Dr. Pradeep Kundu with floral bouquet. Sir, please come up on stage. A big round of applause, everyone. Beyond research, I would like to add, beyond research, Dr. Kundu is a passionate educator guiding young engineers to advanced courses and digital twins operational management and smart maintenance strategies. His impactful contribution to both academia and industry have earned him recognition as one of the rising leaders of AI industry. Sir, the stage is yours.
Can you switch this?
Open. You just push it up.
Yes, yes. Hello. सर इसकी बैटरी लो हो गई, आई थिंक ब्लिंक कर रहा है मेरी. इट्स ओके देन आई कैन टॉक फ्रॉम. तो यार मैं सिलेक्ट चेंज करूं क्या फिर आप? नहीं, पर बहुत ज़्यादा एनिमेशन है. आई विल डू इट. ओके. हेलो. मेबी देन आई कैन. हेलो. कैन यू यूज दिस वन? हां, ये वाला. हेलो. Thanks, Dr. Robin and the leadership of Sriram College for inviting me for this talk and at this conference. I am Dr. Pradeep Kundu and I'm currently working as it was already announced, as assistant professor at KU Leuven in Belgium. And the topic which I chosen for today, it's like more like an interdisciplinary topic, like how you use the industrial artificial intelligence. You know, we all are talking about AI, ML every day. I think nowadays we are using it in our mobile phones as well, okay? But I found that even many of the people, they don't know how it really works. They really see like, you know, it's a very complex thing. No, that's not a complex actually. And that's why I try to put my topic that in a very, very simple way so that you can easily understand and purely from mathematical point of view. Because I can understand, I think maybe here the students from different domain, maybe some are from computer science, electrical, mechanical. I don't know your background, but I assume that you are from different engineering background sitting here. So in my talk, I'll focus like how you can really make these AI models, machine learning models, okay, and purely going in just very simple mathematical point of view. I think you all already read about like linear regression and regression kind of models. So I'll try to go that way. First about myself, I did my master's from IIT Indore in 2013 to 15, and also I did my master thesis from GE Bangalore, India, and then I did my PhD from IIT Delhi in 2016 to 2020. After that, even during my PhD also, I got a fellowship and I was part of the overseas visiting doctoral fellow at University of Alberta, Canada. Then in 2020 to 2022, I worked as a research associate at University of Strathclyde in UK. Then I worked as a postdoc at University of Cincinnati, USA. And currently I'm working as an assistant professor at KU Leuven, Belgium. It's a university like world ranking 60. About my research keywords, which I work on, like it's industrial AI, digital twins, predictive maintenance, fault diagnosis and prognosis, predictive metrology, quality control and reliability. And in my research, what really I'm trying to work, because we all are talking about AI, but this AI model, they really need a lot of data, okay? Because right now we are using ChatGPT and like some other kind of large language model, but you don't know like how much data these models really required. But if you talk from mechanical systems perspective, this data is not really available. You can see it's almost impossible to available. So through my research, what I'm trying to do, how you can overcome this issue, how you can generate some kind of virtual data or you can say synthetic data, so that you can overcome the data dependency while making these AI models. And in the past also and currently also, like I'm collaborating with a lot of industries. Like in the past I worked with like NIST, Hywind, Mitsubishi, GE Power and Water, and currently also I'm trying to collaborate with Siemens, CNH, and control engineering and Manovation kind of companies. About my university, it's like a very, very big university, like very global university. We have almost 63,000 students capacity, so you can see the numbers. And we have almost 49 bachelor program, 137 masters, and 43 are like advanced masters program. And we have almost 14,000 students, so you can say almost 1/4 are like international students. So it's a purely international university, and currently world ranking is 60. And in the university, I'm part of the faculty of engineering technology, and that's because we have the different faculty like engineering science, biomedical, engineering technology, and I'm part of the engineering technology, and we have almost 7,000 students in that faculty. The university itself, it's a very, very big university and a lot of campuses. So you can see in this map, this side is the German border, in the above like the Netherlands border, and on the left is the sea. So the university spread across the whole Belgium, and I belongs to complete west campus of the university. That's what we call as the Bruges campus. It's a very beautiful historical town, or you can say the whole city is like a UNESCO World Heritage Site. And in the campus, like you can see one of the building, that's the city center. You can say they have very beautiful canals and very historical buildings. And there, like I'm part of the M group. That's what we call as the mechatronics group. There we have the professors from the mechanical, computer science, and the electrical engineering peoples. And we made a team, and then we really try to focus on the interdisciplinary research. And then we have like very, very good facility also if students want to really work on their projects, like ultimate factory, ultimate machines lab. And there you can really generate real industry data, or you can validate whatever you're developing on the real industry scale production lines. Now let's jump into my talk. Because whenever we design any component, like mechanical, electrical, you can see here a lot of components. You can see the fan here, lights here, table, chair, everything, okay? We usually design them for like at least 10 year, 15 year, 20 year life, but still they fail. I think right now also very recently tragic accident happened in Gujarat. Air India crashed. The aircraft got crashed, okay? But still we don't know the reason why it got crashed. Still we are figuring out what was the reason for that. But if you ask from Boeing, they design these aircraft, even they put very high factor of safety. They design it, they test it very heavily, but still they fail, because there are multiple reasons for that. We really design these components for like 15, 20, 25 year, 30 year life. Even you see at your home also, sometimes your fan fail in just maybe in 1 month, 2 months. And sometimes, fan works for like 30, 40 years. Nothing happens to that. So there are a lot of reasons for that, like how you're installing them, how you're maintaining them. And that's the same thing with mechanical systems as well. For example, if you see here, this is also one of the example, like, there is a gearbox failure that leads to the whole aircraft failure, and that leads to the life of the 16 people life. Now, you can see second example on other side. Sometimes we see, oh, these components are really, not very expensive, bearing, gears, you can say fan. We see that, okay, they are cheap price. Why we should do this maintenance? But now if this fan is there and if this fan fall on someone's head, that person will be gone, okay? So now we have to see the impact of it. And that's the, if you see in this figure also, like, there is a bearing fail actually in one of the wind turbine, and the bearing costs like almost like 1 lakh rupees. But that wind turbine costs 50 crore rupees. So you can imagine that just 1 lakh rupees, just very small component, if that component fail, it leads to a 50 crore rupees whole wind turbine. So that's the impact of this failure. And what I'm trying to do through my research, how you do the condition monitoring of these systems using AI, because there are some hidden, because what we do usually, we put some sensors on these systems, we analyze the signal, we process the signal, then we extract the feature out of it. And now you can understand, now you'll say, like, what is feature actually? What do you mean by feature? It's like, I think you all know, like gold mining or other kind of mining activities. No, it's the same way, okay? We have the data, and data contain a lot of information what you're expecting. But the information which is really required, that is really at minimum scale. So similarly, like, if you talk about gold mine, okay, gold mine, like, it's a very big mine, like 100 of kilometers spread across. But the gold, if you see, quantity of gold will be just very, very less there. Because there are sand will be there are other things will be there, and then you have to mine the gold out of it. The same thing we do in the features engineering as well. That's what I will talk about in my next slide. Now let me show you other example. This was even like happened when I was really performing experiment by myself. And if you ask, even this happened 3 a.m. in the morning, because when we run this rig, we have to run it completely. Because it's a run to failure. We are failing this system intentionally, because to get the data to understand how they will fail. And when we start this rig, so we don't sleep for 7 days, 8 days, because it's a continuous operation. We sleep obviously, but we sleep maybe after 1 hour, 2 hour alarms, okay. Now, if you see here, there was a bearing failed. You can see the condition of the bearing, okay, and that is part of one of the motor. If you see in this setup, now this bearing got failed. But can you imagine if this bearing got failed? It was just around 10 euro, or you can say 1,000 rupees, Indian rupees, okay. Now, because this bearing failure, there was some kind of torque sensor was there. There are some DC motor windings there. There was a bearing there, and then there was some hardware, other hardwares. If I count everything, there was almost 3,400 euro hardware cost loss, or you can say almost 3.5 lakh rupees. Now plus production cost. I'm not considering, if for example, if this machine was part of some production line in a factory. So now you can imagine 3 months of production lost. So you can imagine that almost it's 340 times. Just 1,000 rupees item leads to impact of 340 times. So these are the problem, that's why we need to monitor these systems. Now how we are doing it? That's what we call this field as asset performance management. Perform the condition of these assets. And how it started, like, till 1950s, we usually have corrective maintenance. Corrective maintenance means if something fails, then only we go and check and repair. And that's what we do it for our household component, like, mixie, fan, motorcycle also, unless they don't start producing some weird noise, we keep on operating them. Even after they produce the noise also, we still keep on operating them, because we are really very, very busy, and we don't have time for the repair of those systems. And when we go for the repair, one day maybe we stop at a highway, okay, because of the motorcycle completely stop. The same thing we follow. We used to follow complex systems as well in 1950s. Then we come up with the idea of periodic maintenance. Like, you define some period, like 3-month interval, 4-month interval, or some kilometers. For example, when you buy your bike or motorcycle or car also, then they will tell you after 3 months you have to come for the some maintenance. And what they do, but the problem with this periodic maintenance is that when you even go for the maintenance activity also, okay, the biggest problem there is that maybe your component or machine can fail before that. It could happen, or either you go and repair something that is really not required replacement. So you are doing over maintenance. So that's why they should be optimal, and that's the after 1980s, sensor technology become really advancing by time. Then we have the very good sensors. Sensor means what? Like, for example, our human body also, we have sensor like thermometer. Thermometer is a kind of sensor to monitor the body temperature. Then similarly, we have ECG, some MRI, X-rays. What are these? These all are like sensors. So similarly, for mechanical systems or electricians, we have sensors like vibration sensor, noise sensor, temperature sensor. So now the sensors become advanced. Then we put sensors on these systems. We directly monitor the data from these systems, and then we try to monitor what is indirectly really happening in that system. Then after 2000, then we have very good computers. We have i3, then i5, i7, i9, okay, and now I think maybe we have maybe more advanced processors. And that's why, see, now people say ChatGPT. ChatGPT is there. No, ChatGPT even was there 40 years back. If you really see, it was 35 years back as well. If you see, the first large language model was developed by some Japanese professor 30, 35, 40 years back. But why it's successful now? Because now we have the computing power. Because at the time we don't have the computing power. Whatever you study in AI, ML, whatever field, okay, AI, ML is not a new field. It started 50, 60 years back. If you see the history. But why this AI, ML, become crazy after 2000? Because we have the good computers. We can make these models on those computers. Because before 2000 we don't have the good computers, so we don't have the resources, okay. Since we don't have the resources, so then what we used to do? We used to just, some people have just the resources available, and then they can only use those resources, okay. But now technology has been changed, and the same thing with this condition monitoring application as well. There what happened in the past, we just do whatever really happening now, wrong or correct. But now in the future, because see, for example, if you talk to any other, because right now we can see electricities are there. But why these are there? Because we have the wind turbines operating somewhere, gas turbines working, coal plant are working, okay? Different type of plants are working. But now if I go and say these people, especially in the summer period in India, if I go and tell them there's something happening wrong in your system, please stop this machine. They'll say, no, we cannot stop this because there is a huge electricity demand. Maybe in Gwalior, Jabalpur, Indore, whatever the region being it is. But what they will say, okay, in the winter or in September, October, electricity demand is less. Can we stop this system in September, October? But how AI help there? AI help in predicting the future. Okay, right now, this is the condition of my system. Can I stop this system can I work still this system for next 30 years or not? So not 30 years, like 30 days or 40 days in the future. But how you do that? Using AI, you can predict the future. You can predict that, okay, how my machine will degrade in the future. That's why this whole field we called as the prognosis and health management, this whole discipline. And it is inspired by three things. First, you should know which sensor I should use. For example, if you have fever, you don't go and do the X-ray. For fever, definitely you monitor the you will use the thermometer. Okay? So you should know that which sensor I should use for that. Second is algorithm. Sometimes, people always see, because that's why, I also want to tell you, AI ML is really very, very easy field. Very, very easy. Because, for example, if you see your core subjects, like mechanics in mechanical engineering, mechanics is more tougher than the AI ML. Okay, dynamics is more tougher than the AI ML. Even in your computer also, maybe you have more complex subject than AI ML. But if you really ask me, AI ML is really, if you know just a little bit mathematics, AI ML is really very, very easy, most easiest thing to learn. The only thing, that's why you should spend your more time on data, because data is the gold, okay? If the gold quality is bad, your model will be bad. If gold quality is good, your model will be good. If you give the noise, output will be noise. Sometimes people think that, oh, if I give something, my AI model will work. And that's why I think many of you are also afraid. Oh, I will get the job or not, okay, AI will take all the jobs. No, that's not true. Okay, AI will take definitely many of the jobs, but not all of them. The only thing is that now you should know the AI just like a mathematics. Okay, there is nothing new in the AI. It's been there in your 12th class. I think you all already read linear regression. I think you already read in your 12th standard linear regression. That's a kind of also AI model, okay? You have some data, you feed the model, you get some parameters, and then you predict something. That's also AI. That's the really, for example, if you want to learn AI, just go and learn linear regression first. And then go to, because the problem is that, we go and start doing just some complex models. So now, that's the algorithm. And third part is that sometimes you can make really complex model, complex algorithm. For example, now ChatGPT is working there, okay? But there are very big databases, like data storage things are in the US, okay? They are burning day and night. Because you need very high computational power to learn these ChatGPT models. Now, how this field work, okay? For example, you have some system. What we do first, as I told you, we put some sensors. We monitor the health of these systems using these some kind of sensors. After that, now the problem is that, for example, you see, I think most of you have seen your MRI image or X-ray, definitely. But when you see this image, you always see a lot of noises are coming. Okay, but for example, if you see the raw image, that's really very noisy. But behind that, there are a lot of algorithms there that really filter out everything, and then it really gives you very, very clear picture. That's what you see. But behind that, there are really a lot of complex models are working. That's what we call a feature extraction. Feature means something you have to get out of it. Feature means, like, for example, if you have, like, for example, if you have some kind of disease, okay, you go and doctor will check it. Okay, and then there is a different feature for different kind of disease. Maybe if you have cancer problem, doctor will take like maybe your MRI scan or CT scan. Okay, someone has heart problem, the feature is ECG scan. Okay, your heartbeat is a feature. If you have fever, temperature is the feature. Temperature value is the feature. So that similarly in the mechanical systems also we have the data, but there are a lot of informations there in the data. And then we have to get information out of it. What feature does my model need? For example, theoretically, when something degrades, something fail, so with the time, it value increase. So similarly, if you see the feature value should increase with time. Then we have the identify the fault. Fault identify, let me give you the example with the human body also, because this field is really inspired from the biomedical field first, okay, medical field. Now, what really work in the medical field? In the medical field also, for example, let's example someone has cancer, okay. What doctor will do? Doctor will put some sensors on the human body, take the samples, then they extract some feature, then what they will do? They identify what kind of cancer this person has. Because for every cancer, there is a different treatment. Okay, blood cancer, different treatment, throat cancer, different treatment, okay, skin cancer, different treatment. So similarly, using your AI model, you should know that my system is failing because of what kind of failure. There could be multiple reasons for that failure, and then we have the multiple treatment. For different failure, we have different treatment. Then next aspect, the fault prognosis is future prediction. Now you know that my component is right now in this health stage, but I cannot stop this component. Can I run this component next 2 months, 3 months safely or not? That's what you call the prognosis, means future prediction. Now let's again take the example of cancer as well, okay? Sometimes, for example, someone in the stage 4 cancer, doctor will say, no, this person will survive only next 10, 15 days only. Someone stage 1 cancer, that person will survive maybe next 4 years, 5 years. How they do it? Because they have the models. They have historical data. Based on data, they train those models, and by training those models, they know that if this person has this kind of cancer, this person has this much survival probability. This person can survive this for these many years. So similarly for mechanical systems also, we don't stop this component in the real time, because we want to run the machines as most of the time, okay? And that's why that's what we call the prognosis with future prediction. And then we predict this future, then we send this to the maintenance department. Either they have to do the maintenance activity or no maintenance activity. Now, what's the purpose of this whole field, what we call as prognosis and health management? The idea is that you can always use multiple sensors, like vibration sensor, oil sensor, thermography, noise, heat sensor, smoke sensor. But the purpose of whole field is that we want to predict something as soon as possible. Okay? Because see, so for example, if you see the cancer people survival probability 10 years back was really very, very low. But now many people survive the cancer. Because now we have the advanced sensor, we have advanced technology, we can detect the sensors before time. That was not the case 10, 15 years back. So similarly in the mechanical systems also, we try to find the sensors, we try to analyze the signal in such a way that we can detect this system failure as soon as possible. If you detect early, you can avoid the critical failure. Okay, so for example, I told you the Air India crash, if they had, maybe some of their sensor got failed, or they didn't maybe monitor properly something, and that's because of that, they were not able to detect it. If they would have detected earlier, then we could have saved 270 or 280 people easily. Now, for this field, as I told you, there are multiple algorithms. Maybe you heard about neural networks, support vector machines, linear regression, logistic regression. But now you have to understand one thing. That's why I really like the statement by George E.P. Box. Okay, all models are wrong, some are useful. Every model has advantage, every model has disadvantage, and you have to see always which model is work in your favor. So for example, if you really want to work on AI things, okay, you don't need to worry, you don't need to afraid. Even people with 20-year experience not able to make a good AI model, and maybe you can make this good AI model because just with a fundamental mathematical understanding. because there is no unique model in the world. Still, okay, people think AI just you give something and something will come out. No, it's not a magic, okay? You have to really carefully analyze your data, analyze your signal. You have to carefully really develop algorithm. You should know that what algorithm will work on my data. And that really come with experience, that really come with some kind of mathematical understanding. Let me give you just very simple example, and then I will conclude my slide. For example, if you see this mechanical system here, okay, you can see here there is a motor. If you see here, this is the motor, and then we have the gearbox, and then there is a pump. Now if you see, this system looks like a simple system, but you know there are 3 components there. Now what happens? Every component has its own dynamics. And what I mean by dynamics, you know, for example, now I think we have almost 500 people here. We all have different dynamics. You know, someone will maybe, I want everyone live for 70, 80, 90 years, but you know, someone will die early, someone will die late, because you know, our body, what we eat, what we feed to our body, okay, that's how our body react as well. Someone will have then, you know, after 50, sugar disease, someone will have high cholesterol, high BP, whatever. So the same thing with mechanical systems as well, how you operate them, okay, how you really operate them, and that defines their life as well. And that's why, like, you know, every component has its own dynamics. For example, in our human body also, heart has different dynamics, my hand has different dynamics, my eyes has different dynamics, my nose has different dynamics, my teeth has different dynamics, my voice has different dynamics. So that's why, for example, now in this system, if you see here, we put some sensor, we analyze their signal. If you see that, this is how the amplitude is increasing with time. And then, you know, sometimes what happens, the people with the shop floor, they don't understand these values, you know, values could be anything. And then we normalize this value. If you see 1 means something is really good, and 0 means something got failed. Now idea is that at point P, maybe like I see that something is happening wrong in my system. But now company will say, no, I want to stop this system till level 0. And that's what we have to predict. Like that's what we call as a remaining useful life, predict. Now how you can do that? If you see this, you can use simple linear regression. I think you all know about linear regression. You know, y is equal to a0 plus a1 into x. If you use this model, and then there could be like higher model, like second order polynomial, third order polynomial, okay? And if you see this, particular for this example, here black line, like magenta line is basically actual remaining life, and the black, when you use the third order polynomial, if you use second order polynomial, error is high, and if you use the linear regression, okay, error is really high. The reason being is that, if you see your feature, you know, how it is increasing, it really increasing like, you know, non-linear way with time. That means you should use some kind of non-linear model. That's how you really understand what kind of model I need. But can you imagine, this is the AI model. This is also kind of, you know, very small scale of AI model, okay? And you can see that that's what I'm estimating here right now. So you can imagine how much time it will take, just 30 seconds to make these models actually. It's not a big deal actually. That's how it really works. And maybe I can, because since I have limited time, I can skip, because I want to show you some other case study as well. But see, what are my final thoughts, okay? For example, if you want to work in AI, irrespective of any application, healthcare, mechanical, electrical, whatever application you work, you should really first need what I need to model, okay? Because every system is complex. There is no easy system. And that's why these systems are complex, that's why they need engineers as well. If systems are not complex, then companies don't need engineers. Why we need engineers? Because the systems are really complex, and we need engineers in each very micron field. Because see, right now I think you all are studying 48 subjects in your BTech, okay? But right after you go in the job, you will just working on one of your subject, and in one of your subject also, just one of your chapter. That's what you will work in your whole next 30, 40 years life, even if you go in the industry. Okay, and that's why they need, because to develop something, that's why you need to understand really what I really need to model. Second is that what feature my model is really required. Okay, for example, if someone has like someone has a heart problem, don't go and measure their body temperature, because body temperature, nothing has relations with the, like, you know, heart disease. If someone has cancer, don't go and monitor the body temperature, because you have to go and do some MRI and CT scan. So the same thing, like you should know what feature my model is really required. And most important fact is that what are the modeling trade-off. And what I mean by modeling trade-off, I told you, I think if you remember, I saw you statement, every model has advantage, every model has disadvantage. And you have to really find out which model will work in really on your data, on your application. So it's not a really, like if I summarize, it's not a really complex problem. AML is really very easy. I'm honestly telling you. If you know just very basic level mathematics, even 10th level mathematics, you can really make a very good AI model. Okay. The only thing you just go and go and deeper into mathematics. Thanks for your attention. Now I'm open for the questions if you have. Thank you.
Hello. If we have any questions regarding the presentation, they are all welcome. Anybody who has any questions can raise their hands. I don't think they have. Thank you very much, sir. A huge round of applause once again for sir. Thank you, sir. It indeed has been a conference. We had started from Jabalpur, we went straight away to Nepal, and here we have sir from San Francisco. Up next, we have sir from San Francisco joining us. So we are on this journey of world tour, and we will surely enhance our knowledge in this conference today. So let me welcome our next guest who has joined us for an online session. Mr. Nikhil Jain is joining us straight from San Francisco. I am delighted to introduce our distinguished guest today. He has completed his journey and is currently positioned in San Francisco, University of San Francisco as an assistant professor. And he has joined, I think you can see sir directly on the screen now. He earned his degree in finance. Mr. Jain also has a brief history, a detailed history in data science certification, and he did it from General Assembly, reflecting his versatile expertise in both financial acumen and analytical technology. He currently also contributes as well as in academic sessions. He also is the volunteer assistant coach of the San Francisco State University men's basketball team. So he is a unique blend of committed entrepreneur, sports mentor, and a business leadership. With a huge round of applause, I would like all of you to welcome our distinguished speaker today.
Hello.
Sir, I think you can hear us. Hello, sir. I don't feel that you're audible to us.
Hello, 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 hello. Yeah, okay. So, can you guys hear me? Am I audible? Should I start my presentation? I'm asking, should I start my presentation? अपूर्वी जी मैं शुरू करूं क्या? Okay. Good morning, everyone. First of all, a big thank you to the organizer of MPCon 2025 and to the Sri Ram Institute of Technology, Jabalpur, for putting together such a fantastic event. I know how much work it goes into the running a conference of this scale, and I think you guys have done amazing job. Let me introduce myself. I am Nikhil Jain. To be honest, I'm also a Jabalpur product, born and raised and lived across my life, and then moved to US to pursue my education. And now I'm working as a senior partner technology manager at Samsung SmartThings. Along the way, I have also been fortunate to be recognized as senior IEEE member, a Forbes Technology Council member, an IETE fellow, and an SCRS distinguished fellow. So I'm not gonna spend a lot of time talking about my intro, but since you've already had a great technical sessions from last, like this day and yesterday also, like detailed algorithm, architecture, research insight, So What I want to do differently in this session is add another angle, which is business side of technology, specifically how startups, if any of your students in the institute is aspiring to be an entrepreneur, then how they can thrive and how partnership with a giant clients like Google, Microsoft, Amazon, Samsung, um, and they can shape how they can leverage their ecosystem. And my talk title is empowering innovation with partnership, AI startup, and the ecosystem approach. So let me start with why partners why partnership matters. Let's start with a simple truth. Tech giants dominate everywhere, like Google, Microsoft, Amazon. They control the big AI infrastructure, the compute, the data, the platform. Competing head on with these companies is next to impossible for a startup. But here's the good news. Startups brings agility, so it's flexible. You can immediately change your policy or come up with a pivot with a process or technology you are working on. So startups in general are creative and niche focused. Startups can, as I said, they can pivot in few days, while giants take months, sometimes even years. Think of a tiny speedboat versus a giant cruise ship. The cruise ship has a scale, but a speedboat can quickly maneuver into new opportunities. That's where partnership brings scale. The startup contributes creativity and innovation, while the big players contributes reach and reliability. Together, the two can make an outsized impact. I actually have written a Forbes article and just want to give you a glimpse of it. And I can give you a link also about the same. It is about how startups can thrive in an age of AI giants. This will going to give you more insight about startups and how they can utilize the big platforms to be more flourish in a shorter time. Now let's talk about the AI ecosystem and landscape. Um, let's zoom out and look at the AI ecosystem itself. At the center, if you see this uh, image, you have AI ecosystem as a whole. Surrounding it, there are major tech modes like Google, Microsoft, Amazon, Meta, each acting as a powerful hub. Google network is heavily tied up to healthcare or cloud startups. Microsoft Hub has strong enterprise in the mobility connections. Amazon Cloud accelerates startups in energy, logistics, and services. Same with the Meta and their partners works a lot with AR, VR, and smart living, and connected, mostly connecting peoples. The key message here is that the startups plug into these hubs to access resources, credibility, and markets. And if you look at the domains driving innovation, if I come back up, then healthcare, cloud computing, mobility, smart living, and sustainability, you'll notice every one of them needs collaboration. No startup can solve healthcare or sustainability alone. It takes the ecosystem, startups innovating at the edge, giants providing the foundation. It's very simple. Let's talk about technical foundation of collaboration. All right. Partnerships aren't just about handshakes. They are built on real technical foundation. We have APIs and SDKs. These are the plug and play connectors that makes integration possible. Imagine them as a universal charger that lets device and apps talk to each other. Then cloud AI services we have, which is like Azure, Vertex, AWS. They give startups scalable infrastructure, and no startup can actually afford billions of dollars data center, but they can rent compute on demand. So this gives them easy to have high quality of resources and quickly start working on their actual problem. Then we have AGI and federated learning. This is where the startups innovate, running AI locally on devices, keeping data private, and collaborating without sharing a raw data. That's a very key and very important point. And at the last, end users. Ultimately, the goal is uh, deliver value. Fancy tech is uses, and honestly, it's useless. Uh, um, unless it is improves a patient's health, save energy in a home, or makes an employee more productive, then it is useful. Otherwise, it's of no use. So the tech founders are about building blocks that enables collaboration rather than a barriers. Okay, let's flip the coin to business models. Partnerships comes in different shapes. So one is co-innovation, building a product together, then go-to-market alliance, joining forces to reach customers, marketplaces where startups can list their solution on AWS or Azure marketplaces. If you look at this pie chart, and basically it shows three things: market reach, credibility, and customer access. All three are very important. And honestly, uh, startups need all the three things equally and to grow and survive on a continuous manner. Think about it in a way. A brilliant healthcare AI is kind of a meaningless if hospitals don't trust it. Credibility matters as much as tech itself. Cool. Let's talk about the case studies. So the first one is healthcare AI startup. They used AWS compliances frameworks to become HIPAA compliant quickly. I'm just giving you an example that how a healthcare startup can quickly grow. And then normally the process takes years, but because of this platforms, it's a matter of, if not days, at least in few months also you can get started. They managed to accelerate market uh, as less as like 5 months. I've seen that. And then if you're talking about traditional way, it used to take like years. The same with if we are talking about the energy analytics startups. If you partner with Google Cloud for a massive grid data analysis, or even Samsung Smart Things, um, alone startup alone they couldn't process terabytes of real time data. With Google's infrastructure, they scaled instantaneously and landed utility customers. Then another example is legal AI startup. This is getting very, very attraction, specifically in the Silicon Valley. Um, what the legal AI startups they are using, they are leveraging the Microsoft Azure OpenAI services to build legal research solution on top of that. Lot of law firms suddenly had tools that was both powerful and enterprise ready because it came on Microsoft's infrastructure. These are just three examples I'm giving you, but there are all like proven one. Lot of companies are already doing it, and the right partnership can be a differentiator. If you also want to be one of the company, or if you want to open your own company, so this is something an infrastructure, or this is something a case study you can get an inspiration from, and you can also work on that. Let's talk about the partnership challenges. Obviously, when you decide that yes, you want to work on this, you also want to open your own, company, or want to solve a problem, and through a partnership model, then there will be definitely a lot of challenges will gonna come, because it's not always a smooth sailing. Uh, so there are challenges like technical challenges, integrating multiple APIs, handling different data formats, making sure security is all right. So that's a one thing. Then there are so much business risk, like IP ownerships or dependency on one big player, and then suddenly they change a policy and your entire companies, is in very high risk. um, Very good example is recently Google I/O. They came up with a lot of features in the Google AI platform, and you've seen hundreds of AI startups. They just got crumbled in just one Google I/O announcements. So that's one of the very big learning for all the startup founders. Then other thing is academic opportunities is also there. Here's where the institute like yourself, here's where the researchers play a huge role. Designing resilient ecosystem, privacy, preserving AI, and sustainable scaling models. So overall, partnerships are powerful, but they require careful planning and smart choices. Okay, looking forward, there are huge opportunities for innovation. Open APIs built on top of what's already out there instead of reinventing. To be honest, I put this open API one because this is one of the highly engaging area of my own work, because I work as a partner technology manager, in which is responsible to expand our own ecosystem, and I provide help with the startups to use Samsung Smart Things APIs and build their application on top of the Samsung Smart Things. So this is one of my very close area where opportunities for innovation is on a day-to-day routine. I work on this concept. Anyway, so talking about the privacy and preserving AI, use federated learning or differential privacy to keep users safe. Then cross-domain solution. The best ideas often happen when you combine fields like AI or healthcare, energy management, or AI for logistics in sustainability. And most importantly, see the ecosystems as an enabler, not a competitor. This is very important point. People think that if I will be a part of this ecosystem, the other people who are also using, they are my competitor. No, exactly, it's not like that. Through the ecosystem you can scale faster. That's a reality of the industry. Smart partnerships don't show or slow down the research, they accelerate and commercialize your research. Okay, so the future of ecosystem and innovation. What does the future look like? We are moving from isolated product to platforms to full ecosystem. In the past, you build one product. Today, you build a platform, other can use that. Tomorrow, the real winners will orchestrate ecosystem, connecting startups, giants, researcher, and government together. That's the journey we are all part of, from code and lab to global impact through ecosystems. Cool. So lastly, your innovation journey starts here. Innovation thrives through partnership, not isolation. So at the last, I want to ask 3 questions here. Who can amplify your idea? Which ecosystem can I help you scale? What business model will sustain your work? If you can answer those questions, you are on the right path. And if this is still not clear, then in that case, you still have to reassess whether this startup or problem solving or something you need to do it not. So these 3 questions are very key. And if you have the answers, go ahead. This is something for you. Otherwise, you have to reassess it. Cool. Thank you again for giving me this opportunity. Thank you, MPCon 2025 organizers and Sriram Institute of Technology. All of you being such a nice and engaging audience. And feel free to, if you have any questions. If you guys want to reach me, this is my website, and you will also going to get my email there. Yeah, that's all. Thank you. Any questions? Happy to take any questions if you guys have.
A huge round of applause once again. If anybody has the answer of the 3 mentioned questions on the screen, they can also raise hands, or if anybody wants to ask any questions, they are all welcome. Or just want to socialize with sir.
Unfortunately, I can't hear anything. If there is any questions, Apurv, can you please type it down? Okay, okay. Then, thank you.
I request everyone to please wait for 10-15 minutes. Dr. Sumajit sir will also join us. He is joining us from IIT Bhilai. So as soon as he joins, I'll give you the brief introduction and then we'll proceed with the next session. Thank you.
Hello, hello. Children, please kindly pay attention here. बच्चों ध्यान दीजिए इधर. हमारे बीच में एक बहुत ही बड़ी इंस्टीट्यूट IIIT-DM के डायरेक्टर एक्सपर्ट टॉक के लिए आपके बीच आ रहे हैं. मेरा आप सभी बच्चों से रिक्वेस्ट है, प्लीज ट्राई टू मेंटेन द डिग्निटी, डेकोरम एंड डिसिप्लिन ऑफ द कॉलेज. प्लीज बच्चों, आप लोग अपनी सीट से मत उठिएगा. एक भी आप लोग बात मत करिएगा. आप लोगों के रिफ्रेशमेंट की व्यवस्था कराई गई है. आपके पास ही रिफ्रेशमेंट आएगा, पर जो वो डिलीवर करने वाले हैं उसको फुल कंसंट्रेशन के साथ सुनेंगे आप. तैयार हैं इस काम के लिए? आवाज नहीं आ रही पीछे से. पीछे से आवाज नहीं आ रही. तैयार हैं आप लोग? वेरी गुड. तो हमारे आज के इस आपके प्रदर्शन से कॉलेज का एक अच्छा नाम जाएगा उनकी नजरों में. प्लीज आपस में बात नहीं करना है, उठना नहीं है. रिफ्रेशमेंट आप खाते रहिए. डोंट टॉक विथ ईच अदर. अब तो एक दूसरे से बात मत करिए. प्लीज साइलेंस मेंटेन करना है. क्लियर है? ओके, ऑल द बेस्ट.
for the type of award, which is academic award and so on. So basically, given a question, once you need to understand that this Oscar and Academy Award are the same things, and Nolan and Christopher Nolan are the same person. So once you are done with this understanding, you can extract the most relevant part of the knowledge graph, and then you can try out these different types of methods. So you can try to do some traversal, etc., and try to figure out what is the answer. Now, as I said, the good things for knowledge graph is that it is mostly human curated, and so it is very reliable and everything. However, the main issues here is that it is incomplete. So there are many recent facts which are not there. So these are not so much frequently updated, and the facts which are like ephemeral, for instance, which are short living basically. So for instance, suppose there was a match maybe yesterday, and who lost in that match. Now that might not be very important to be added in a knowledge graph. However, today I might be interested. Say if there is a match between say Liverpool and Manchester United, maybe I'm a Liverpool fan. I might be interested in knowing that what happened to that match. But that is not some information which is so important. This might be a very common league kind of thing, which might not be there in the knowledge graph, right? And similarly, the knowledge graph also have some limitation with the number of properties. So for every knowledge graph, we have, like for instance, if you see, so there are some properties like country of citizenship, name in native language, birth name, and so on. And these are something which are already fixed. So the people who have designed the knowledge graph, they have fixed that these are the set of properties we need for every human or something like that. So every type of information, you might not have it covered in the set of properties in the knowledge graph. So the general overview is that knowledge graphs are very good, but they might not contain all the recent information or all the varied information which are needed for answering your question. Now, coming to the other kind of source, for instance, these textual sources, right? So in case of textual sources, the idea is that mostly like Wikipedia or other kind of knowledge sources what you have. So given again any question like how many of Warsaw's inhabitants spoke Polish in 1933, so you can extract your relevant documents from Wikipedia or any other web source available over internet. So you'll get certain documents from there, and then from the documents you can retrieve this information like this 8,30,500 and so on. Now for that, typically we use machine learning based approaches. For instance, nowadays, you know, I mean, transformer based approaches are mostly used. So given the question and relevant paragraph, they will try to figure out the relevant span, right? The answer span basically, that what is the starting point of the answer, what is the end point of the answer, right? Now, the issues here is that because all you you all understand that because this is dependent on internet or web documents, these are noisy, right? So whatever fact is there might be unreliable, unlike knowledge graphs, right? And retrieving relevant documents is more difficult there, and so as a result, I mean, it is not very accurate. Okay, so many times we make mistakes. Now, in this situation, what we thought that what if we try out unification of these both sources? That can we make a system which can work on both knowledge graph and text and take the good things from the both the worlds basically, right? So with that motivation, we started this work and tried to see that if that can improve the state of the art for complex questions. So the main challenges what we faced while doing this unification are this that there is a inherent incompatibility between these paradigms, right? I mean, this standard KGQA systems what you have, these are mostly graph based systems, right? Because knowledge graph is a graph. Now those approaches are not very equipped to compute answer from text passages, right? So I mean, there are many methods which are Sparkle query based. There are methods which are graph search or graph embedding based. They cannot work on text inputs as there are no natural underlying graph representation in the text. Similarly, in case of text QA paradigm, this is not equipped to tap into the KGs. So text QA paradigms are something which are mostly machine learning based, transformer based, and so on, and they cannot work directly. I mean, you cannot directly apply that on the knowledge graphs. Okay, so although there exist some algorithms or some methods which claim to support this kind of unified heterogeneous QA. For instance, we have PullNet, GraphNet, some method which came in late 2020. So, but the problem is they typically consider one of the source to be their major source. For instance, for both PullNet and GraphNet, they consider knowledge graph to be their main source, whereas they only take some supporting information from the text, some supporting evidence or something like that. So it is not truly unification of both sources. It is like still they are relying on KG entity embeddings, KG entity link test, shortest path on the knowledge graphs, etc. So mainly they are relying on knowledge graph. Only they are taking some additional evidence from the textual information. So now in our work, we name it as Unicorn, which is coming from Unified Framework for Question Answering over RDF knowledge graphs and natural language tests. So it can handle knowledge graph QA and text QA and heterogeneous setup where we use both the sources with the same unified method. So what we do is generally we build a noisy KG-like context graph and from the KG and or text corpus on the fly using some tools like name entity disambiguation, open information extraction, BERT fine tuning, and so on. So I'll explain the steps one by one. So what is new we are offering? What is the main contribution? That this method can work on only KG as well as only text as well as a combination of both, right? And this leverages both supervised machine learning like BERT transformers as well as unsupervised graph-based methods. We'll discuss group Steiner trees. Both are used by this method, and it is able to handle ungrammatical constructs. So when you are providing the question, it is not needed to be grammatical question, because many times when we say something to our digital assistant, we are not that grammatically correct, right? And then it is robust to high degrees of noise, and it provides explanatory evidence. So this is also something very important, and many of the state-of-the-art like machine learning based models, they are not able to provide the evidence. So although they can give you the answer, maybe they cannot tell you that from this source they have got the answer and this is the method why they think the answer is correct. Okay. So now coming to the outline of the approach, the general approach is that suppose for the textual sources, what we do, we extract some evidences from multiple documents, what we retrieved for this particular question, and we try to score them using a transformer like BERT. Now we augment some type information, some alignment information, and create a noisy knowledge graph like graph, right? So we are calling it XG. We are not calling it KG because it is not exactly a knowledge graph. It is a pseudo knowledge graph kind of thing. So we are calling it XG. And then we'll do some, so we'll apply some graph algorithm. We'll do some question cornerstone identification, some group Steiner tree calculation, and some finally the ranking of answer candidates. Okay. So I'll go to the step by step, but I mean, this is just to give an overview. On the other hand, for the knowledge graph, what we do, we extract the entities from the question, and accordingly from the knowledge graph, we extract the entity-wise facts. And then again, those facts are scored by a transformer like BERT. And then there also we augment types and create a noisy knowledge graph. And then there also we spot our question cornerstones and compute group Steiner trees and anchor answer constants. So you can see that mostly, I mean, apart from these two steps, mostly these paradigms or these things are similar. So that's why we are able to unify it, right? So when we work on both KG and text, we actually take, we actually create these XGs separately for knowledge graph and text. And then we take the union and do the rest of it on the union graph. Okay. Now, let me just explain the entire process by taking an example from the start to end. So, suppose the question, the running question, what I'm considering is which Nolan films won an Oscar but missed a Golden Globe, right? So, given this question, you can extract, like you can pose it to your source of documents, whatever document database you have, and assume that you have retrieved these three documents, right? So one is relating to 2011 Oscar was just announced and so on, right? I mean, this has somewhat common, right? This Oscar is coming here, winner is coming here, like one and winner is matching. Similarly, for this document coming because Nolan is matching here, right? Similarly, this document is coming because Golden Globe is matching here, Lost is matching here, right? So, because for text retrieval, generally we consider this word-wise matching or like entity or predicate-wise matching. So there can be multiple documents which can be retrieved. And our target is mainly to answer after joining the evidence from multiple documents, right? So what we do here is that we try to convert these sentences or phrases what we have in our retrieved document into some subject predicate object kind of triples, right? So this is subject predicate object kind of triples. So for that, we generally use a kind of a pattern based open information extraction. So open information extraction is something like extracting these relations from any document, but we do not use a very standard tool for that. Rather, we create our version of this. So we consider, like, if we have some noun here and some noun here mediated by some verb, then we can consider that x, v, y is a triple. Okay, so something like that, some rule based extraction of the triples we do. And then once we get the triples, then we can score the triples. So we can actually create a database where if the triple contains the answer, we can consider it to be a positive sample. Whereas if the triple does not contain the answer, then we can consider it to be a negative sample. And then we can train or fine tune a transformer to score accordingly. Okay, so this is like 1:5 ratio with positive and negative. We can do that. And then we can extract the top K triple. So once we train it with a set of questions, we can, for our test questions, we can extract the top K triples from there and the corresponding scores also. Now see that this is, assume that this is the graph you are getting from the SPO triples which you extracted from the documents, right? So you can see that, so basically these triples, right? So you can see that Nolan directed Inception, Inception 1 bass sound, and those things are there, like Nolan directed Inception, Inception 1 bass sound, and so on. So you can just connect all these triples and you can create a graph, right? So this is what we are calling XG. Of course, I mean, we'll enhance this graph with multiple steps. So first we create this graph. So from we form this noisy quasi-KG that join evidence from multiple documents on the fly. Now what we do, we add some type information. So for instance, the movie Inception is a science thriller, Social Network is a film, right? So how we do that? We generally explore some a method called Hurst patterns. So in the document, if you find like X and other types, so for instance, the movie Inception and other science thrillers, if you find such patterns, then you can understand that the movie Inception is also a science thriller. Or something like films such as The Social Network, then you will understand that Social Network is also a film. Okay, so in this way, you can extract type information from the documents and you can add those type information in your graph. Now, after adding this, we add some alignment edges. We try to understand that this Inception and Inception script are the same entity. Basically, they are referring to the movie Inception and so on. Nolan and Chris Nolan are the same person. Golden Globe Award and Golden Globes are the same thing and so on. So this step is basically the alignment step. And what we do is mostly we use character engram overlap as well as some kind of word vector or word level similarity for adding this alignment edges. After this, for simplicity, we remove the directions, the age directions, and that is not very necessary for our purpose. And we consider all the ages as homogeneous and undirected. Now, after this step, we calculate the similarities of these words, whatever is there in the graph, with the words which are present in the question. And accordingly, we get some scores. Okay. So basically, compute node weights using similarity with the question words. So the ones, suppose you can see this Nolan is there, so that's why Nolan is 1, right? Chris Nolan is getting 0.9. But the words like science thriller, which does not exist directly, maybe in some word to weight, it is similar to film or something like that. That's why it got some score. Okay. Now, we can see that there are some nodes which are very highly similar, right? So there are some nodes like Nolan or One or Chris Nolan which are highly similar, but there are some nodes like director of, type, inception, which are not there, right? Which are not highly similar. So we are calling these nodes which are above some threshold similar with some question word as cornerstones. So all the words which are marked here in yellow are basically cornerstones. So we identify cornerstones by thresholding node weights. And then we can identify, so this is a very interesting thing we observe here, is that these cornerstones, if we try to connect using some path, typically the answers to the question lies within those paths. Okay, so if you logically think also, basically you are trying to connect some words from the question through this graph. So automatically the answers actually lie. So suppose you're trying to connect now Nolan to Golden Globe, this Inception, the movie Inception, all are actually lying within the path, right? Which is actually the answer to the question. So that means answer lie on paths connecting the cornerstones. Okay, that is our observation. Now, what we also see that typically if these paths are shorter paths, so they are generally more reliable, right? Because when you are having longer paths, the question words are apart, so automatically they are not that much reliable. Now, so if you remember, we calculated the scores from BERT, and those scores we now add to our ages. So we insert age weights which are coming from BERT scores, and then basically we consider, of course, higher weighted paths are now better, right? I mean, because BERT already is telling you which ages are more useful, which ages are less useful, and so on. Now, finally, so we are getting this quasi-KG with some nodes and ages and type nodes and age weights and node weights and everything. And we know this information. Answers lie on path connecting cornerstones. Higher weight paths are preferred and shorter paths are preferred. So here we bring the concept of Steiner trees. So Steiner tree is a type of tree where we mark a subset of vertices from a graph as terminals, and we try to find out the minimum cost tree containing all the terminals. Okay. So we identified that here we can actually consider the cornerstones and terminals, because we are trying to construct a tree which contains all the cornerstones, so that the answer lie within that tree. But we observe another thing, that these cornerstones actually appear in groups. So there are multiple cornerstones for the same corresponding word. Like for the question word Nolan, we have Nolan as well as Chris Nolan. So for Oscar, we have these 2011 Oscars as well as 83rd Academy Awards, and so on. So there are groups of cornerstones which are appearing, and ideally it is fine if we can figure out a tree which contains maybe Nolan from this group, maybe Oscar from this group, maybe Golden Globe Awards from this group, and so on. So having one from each group is itself satisfied, or it's sufficient. So we now use that a concept of group Steiner tree. So what we do, that we need to contain at least one terminal from each group, and then we compute the group Steiner trees. So we apply a dynamic programming approach, and which is taken from 2027 paper. 2007 paper, and we apply that. Now, what is happening after you extract this group Steiner tree from this? You will get a tree something like this. So you'll have all those words from the from the question, and then you get other words which are connecting them and forming a tree. Now, our hypothesis is this tree generally contains the answer. Okay, and you can see that. I mean, this inception is coming. The social network is also coming. I mean, the other words are also there. So then we apply some additional criteria that answers need to be nodes, of course. So we remove the edges from this group Steiner tree. We know cornerstones are not answer because cornerstones are directly coming from the questions itself. So we remove the cornerstones. Answers are definitely entities. They are not predicates like announced or one or something. So that means the non-entities are gone. And we respect the type constraint. So we know the answer has to be a film because it is asked which Nolan films won an Oscar. So the answer need to be a film. So that means we can remove the other two. And then we can do some kind of ranking. So we have these two options for our answer. We can check that if we take out the top k group Steiner trees, then in how many of them inception is coming, how many of them social network is coming, how weighted they are, how close they are to the cornerstones, and so on. And based on that, we can rank them and we can figure out that inception is the answer. Okay. So this is generally the method which we propose for the text. And the explanation is you exactly know from which document inception has come because you have created the triples. So you exactly know how this triple has come, how the word has come to your graph, and you can give this, provide this as an explanation to your answer. Now, the same method you can actually apply to the knowledge graph. So what you can do is that you can, given the question, you can again apply some named entity recognition tool on this question and then identify this Nolan, Oscar, Golden Globe. These are the entities which are present. So you can have the corresponding pages basically from Wikidata or any knowledge graph, and then you can extract the facts, right, which are associated with them. Then you can what you can do is that you can verbalize these facts, like you have Christopher Nolan award received this point of time this. So you can just write like Christopher Nolan award received Indian Film Journalist Association Award for Best Director and point in time this one. So this is a way of verbalizing the facts which are present in the knowledge graph. Now once we verbalize, we can exactly do the same thing as text. We can provide this to BERT, again create this positive negative samples, and we can train or fine tune the BERT to give scores to define facts. Okay. Now after this, the method is same. So we are not repeating here. So after this, again, from those facts, you can create a quasi-KG just like text. So here also you have type information and everything which is available from the knowledge graph. Also you can add the age weights from BERT, right? You can again compute the GST on top of it. You can rank the answer candidates. So in the same methods as text, now on the KG also you can apply and find out the answers. Finally, if you want to do the process on heterogeneous sources, what you do, you take the union of the graphs created for KG and text. You have to necessarily insert some alignment edges, and then on the union graph, you have to compute the GSTs. Okay. So for instance, I mean, this can be especially useful when KG and text gives complementary information. For example, maybe this inception missing Golden Globe can be found from the text sources. Whereas suppose that the fact Nolan directing inception might be missed from the text source but might be coming from the KG source. So if there are situations where KG and text can give you complementary information, that is the time when this is most useful. Okay. So what you need to do, you get the graph from KG and text, you add your alignment edges to indicate which nodes are similar to each other, and then on top of that you extract your group Steiner tree and you figure out the answers. Now I know I'm almost touching the time, so let me just quickly tell the experimental setup and wrap up. So So for the experiment, we have considered mainly LC Quad 2.0, which is a complex question data set. And then we have a set of little smaller set of questions also. And as the knowledge graph, we have used Wikidata. And for the textual sources, we have used the Google's top 10 web pages, right? Given a question, whatever top 10 Google returns, we have used that. Okay, but we can change it to any like Bing or any other web search engine, that is fine. Now, what we found that we have taken different baselines. There are some baselines which are specific to KGQA. There are baselines which are specific to text QA, and there are baselines which claims to do both, like KGQA as well as heterogeneous QA. And what we found that generally we are doing better, right? For KGQA, we are doing better than all of them. For text QA, we found that we are not doing the best, but text QA is anyway not our major objective. Our major objective is to show for the heterogeneous QA. And we found that Unicorn, this is our proposed method, this is doing the best across all the methods for heterogeneous QA. And if you see the values here, so they are actually better than the corresponding KG based QA as well as text based QA. Okay, so when you are considering the individual course sources versus when you are considering the heterogeneous source, your results come to be better. And then we tried on smaller data sets also in a zero shot fashion, and there also we found that we are doing the best. These are all precision at one metric, so the top one, whether it is correct or not, and we find that we are doing the best here. And we also did some LLM evaluation. We have tried with GPT-4o and Phi3 from Microsoft, and we found that in a rack setup, we are still doing better from the LLMs also. So of course, we cannot work on zero shot because we need some context information. So we can perform on the rack setup, and we can see that like 0.264 is something which we are getting better. So of course, I mean, we know LLMs are doing wonders here, but for specifically for question answering, Unicorn can provide an alternative which is free from hallucinations, which are a key problem for LLMs. It is free from training like billions or trillions of parameters what we have in the LLMs, and they can provide very simple explanatory evidences, right? So that is which is not that much possible for LLMs. So finally, to summarize, the contribution in Unicorn is it can work with, as we said, it can work with only KG, only text, as well as a combination. It leverages both a transformer, a supervised technique, as well as group synmetry, which is an unsupervised technique. It is very robust to noise and ungrammatical construct. So in the method, never we have used any dependency parsing on anything which relies upon the grammar of the question. There is no decomposition of the question necessary, and it provides explanatory evidence. Okay. So thank you everyone. I conclude the talk here, and any question, please let me know.
Thank you so much, sir, for such a great and detailed presentation. It was so nice to see your research and how the data is being sourced. If anybody has any question, I would like them to raise hands. I don't think they have any questions. Thank you so much, sir, for joining us. It has been such a great session.
Thank you.
Thank you.
Thank you. If anyone has any question and wants to reach me out, my so you can find my email ID from my website. Okay, you can please feel free to reach me. Thank you everyone.
I request everybody to please be seated because IIIT DM's director will be joining us pretty soon. So please be in great discipline in front of him, and your refreshments will be given to you pretty soon. Thank you.
डियर स्टूडेंट्स, हमारे प्रोग्राम के गेस्ट नेक्स्ट 2 मिनट्स में यहाँ पर होंगे. मैं रिक्वेस्ट करूँगा थोड़ा सा प्रॉपरली अपने मोबाइल्स साइलेंट कर दीजिए, अच्छे से रख लीजिए और प्रॉपरली जो बच्चे पीछे बैठे हैं अगर पॉसिबल हो थोड़ा आगे आ सकें तो ज़्यादा अच्छा होगा. बहुत पीछे हैं आप लोग, हवा भी नहीं लग रही होगी. ये जो खाली चेयर्स हैं काफ़ी सारी हैं, अगर इनको हम लोग पीछे वाले बच्चे आगे आ जाएंगे तो दैट वुड बी बेटर. Okay, dear students, let's get prepared. Here is the chief guest of the valedictory function of this International Conference 2025, IEEE Madhya Pradesh Section Conference 2025. We welcome respected Dr. Bhartendu Kumar Singh from IIITM. May I request respected Karsolia sir, Dr. L.K. Patel sir to kindly take our guest on the dais. May I request the secretary of Shriram Group? Okay. Sona ma'am is busy in a lot many work. May I request you, sir, to kindly be seated. Can I request respected principals, Dr. Avinash Gaur sir, Dr. Samir Vaidya sir, and Dr. Shailesh Gupta sir to kindly come on the stage as well. Sir, may I request you to kindly be on the stage, please. Please, sir. Respected Dr. Robin Singh Bhadoria, sir, we welcome you. He's the man behind the success of this particular conference, the organizing secretary from IEEE MP section. We welcome you as well, sir. Good afternoon, everyone. Respected distinguished guests, esteemed speakers and fellow researchers. It is my privilege to welcome you all to the valedictory function of MPCon 2025. Today we gather to celebrate the culmination of remarkable conference that has brought together brilliant minds from around the world to share knowledge, innovate and inspire. Let's take a moment to appreciate the collective effort that has made this conference a huge success. To start the function, may I request respected R.K. Karsolia sir to welcome the chief guest of the program, Dr. Bhartendu K. Singh, Director, Triple IT DM. Can we have a thundering round of applause for the chief guest of the ceremony? May I request Dr. L.K. Patel sir to join respected R.K. Karsolia sir to felicitate the chief guest of the function with shawl and shriffle. Sir, the memento as well. May I request Robin sir also for joining in the photograph. Sir, memento as well. May I request Robin sir and Dr. L.K. Patel sir to come for the photograph. एक मिनट फोटोग्राफ के लिए सबको आ जाने दीजिए सर प्लीज. We have one distinguished academician and researcher, Dr. Vandana Bharti ma'am from IIT Dharwad. May I request you ma'am to kindly come on the stage. And may I request Sapna Chaudhary ma'am to kindly welcome Dr. Vandana Bharti ma'am. A very well-known academician from IIT Dharwad is here. Ladies and gentlemen, please welcome respected academician Dr. Vandana Bharti ma'am on the stage. Now time to felicitate Dr. Vandana Bharti ma'am as well. Please. May I request Dr. L.K. Patel sir to welcome the Organizing Secretary of IEEE MP Section Conference 2025, Dr. Robin Singh Bhadoria sir. सामने से आइए बेटा. Let's join your hands together for the man behind the success of this beautiful conference. Thank you, sir. Now, it is indeed my privilege to invite our first speaker, Dr. Robin Singh Bhadoria. IEEE MP Section Conference 2025 is being led and organized under his able leadership. Dr. Bhadoria will share valuable takeaway from this conference, highlights key insight and future direction in technology, research and innovation. Please join me in welcoming Dr. Bhadoria. Let's have a thundering round of applause, students.
Namaskar sabhi ko. So it was indeed pleasure to share the stage with Honorable Director, sir, Professor Bhartendu, sir, and the Vice Chairman, Karsolia, sir, and Patel, sir, and my colleague from IIT Dharwad, Vandana, madam. So being a part of, IEEE MP section is like dedicated to organize this level of conference at the different part of Madhya Pradesh, and this Madhya Pradesh section conference is very first in the series, started in the year 2025. So for this conference we have received more than 1400 papers, and out of 1400 papers we have selected only 155. So it was like more than 12 or 15% of acceptance rate. So this shows the rigorous reviews conducted by more than 2,000 reviewers sitting across the world. Because conducting international conferences have the flavor for the people sitting at the different corner of the world. विश्व के अलग-अलग कोनों से लोग पेपर सबमिट करते हैं और अलग-अलग देशों से बैठे हुए उनका मूल्यांकन करते हैं. So बात यहाँ विचारों के आदान प्रदान का है, and moreover the practice is involved in reviewing the practice. So most of them are blind review, so that's intact the quality of the papers what we are accepting. And due to the impact of COVID era, so IEEE has allowed the hybrid mode of presentation, and though we have session chairs coming from the different part of the country, madam came from the Dharwad, I came from NIT Himachal Pradesh, so speakers and we have keynote coming from Nepal, Dr. Arun Kumar. He's from Tribhuvan University. We have keynote from Belgium, LU Belgium. That is the QS ranking 60 in the world. So like that's also intake the like delivery quality of the MP section. And other than this, like MP section is, IEEE MP section is also allowing the different engineering colleges, like private, government, both across, and even they are in the collaboration fashion also. So the role of the, like as a publishing, what we call as a, IEEE is a publisher. So the primary role of the publisher is to intact the quality of the paper that is being available at the IEEE Explore. So this being a very good start for this series, and this series this is one of the flagship conference of IEEE MP section. Moreover, there are other like series that are running under the flagship of IEEE MP section. So by the time, different time courses within the year and couple of years, so like IEEE is also contributing technical fundings, technical co-funding, financial supports to the different institutions just like Shri Ram College. So once again, I congratulate the Shri Ram College SRIT Jabalpur for taking all the managements and all the organization of this conference. So with this word, I'll take permissions to withhold my speech. Thank you, everyone. Thank you very much.
We were listening to our very renowned academician and researcher, Mr. Robin Singh Bhadoria, sir. He's from NIIT Hamirpur, head of the Department for Computer Science Department. Now, I was a student of geology, and I used to study about Dharwad succession, a very, very renowned succession in the field of geology. We have an eminent faculty from IIT Dharwad, Dr. Vandana Bharti ma'am, who has contributed to the success of this con. May I request you, ma'am, to kindly come forward and present your experience about this conference. Let's welcome Dr. Vandana Bharti.
Namaskar. First, I will tell you that it's great to be here to give such a talk on artificial intelligence. Basically, I have discussed the specific topic, generative AI in the healthcare, but there is a wide scope also. But before that, I definitely congratulate all the Sri Ram Institute faculties, all the dignitaries on the dais, that you have organized very well. And students are also quite interested, because during talk, I have interacted with the students, and the whole sessions, it's like interactive, because I was asking, I am observing a student also. However, most of them are the first year student. They are quite curious about the AI. And I told them that what is the drawback, where they need to focus. So it's great to be here. This is the first time for me in the Jabalpur. So it's currently the organization and everything, they have quite supportive. Dr. Sapna, I think she has done an incredible job. So I think, thank you. But for a student, as an academician, as a researcher, I'm telling, because recently I have visited to present my paper in a top-tier conferences in France, as well as in the Rome also I have presented. Few papers during my PhD I have presented in a USA. That is the top-tier conferences on evolutionary computation, GECO. So my experience is that it is not only for the MTech and the PhD researcher, definitely, because currently that the second year student of BTech in computer science, they worked with me and they have done the publications. It's only that you should be curious and you should have a good guidance that how to do that. And currently the AI, it's you know that everywhere that it's AI, even in your smartphone, whether you are using during the coding, you are doing the assignment, you are taking the help. ChatGPT is not only the AI. ChatGPT is only one type of model in the AI. AI is a very vast. And I think in the Jabalpur, there are a lot of scope of working from the AI. Okay, not only because see, in the north, we have a lot of opportunities. Here you have an agriculture land. You have so many problems that you can formulate it and you can solve as a student, because as an AI developer, as a India, need to contribute to the society, because IIT is also doing that. We are doing the research earlier for us and the industry, but now we are also shifting towards the community, towards the like a society. So healthcare industry is the one of the most factor. I had discussed a lot of things during my sessions. The second one is the agriculture industry. Third one is the educational industry also. Suppose it is not possible that you have a faculty of every expertise domain in your industry, but there are a lot of resources. Can you formulate, can you find that which is the best suitable lecture, and after that which course I should go through? It should not be the paid courses. Definitely there are a lot of possibility in the free courses, whether in the India, from the IITs also, from the abroad also, that you have a Stanford, MIT courses also, that they are the free course. So learning, that the resources for learning, it's not a limited, it's open for everyone. The only thing that as an academician or as from the IIT, I want that you should be curious about learning, okay? Don't find the excuse. Since you are here, I just want that if you want to pursue the AI, even the IIT, you have a triple IIT in this area, that is the one credible thing for you, that it is near to you. You contact the professor, you work in the collaboration, give a proper solutions, okay? Because AI, it's a broad term, everyone, because whenever we got the internship application, people are asking that we want to work in AI. See, it's a very broad term. If you want to work in the computer vision, autonomous vehicle system, agriculture, or sequential data, time series data, you should be aware that what you want to do. And the second suggestion what I want to give from the IIT side, when you are writing an email, please don't use a chat GPT, because otherwise all interns application are same. So avoid that. In that case, we are not looking those CVs, okay? Because we are thinking that at least you should write your email at least from your side. Because everyone is writing the same thing, looking forward, and these things, same area that I have this strength. Please avoid those things wherever you are applying the internship, as well as in the company also, because they are not looking that you should be aware with the tool, but you should not be completely dependent on the tool. You should have your own IQ also. You don't lose IQ with these AI tools, okay? And AI, that a lot of research is there, computer vision is there. Computer vision, since it's like a combined crowd from the first year to every, it means image or video if you are taking, that is the computer vision. It's not only that computer science people can do. See that we are working with the, I think, Caltech professor, okay, in the physics, astronomical data. It's from the astrophysics, okay? Quantum technology, which is booming now, it is combining with the AI. It is coming from the physics side, right? If you know base, I am not telling that you should understand whole physics, but you are engineer, but the core is from the physics and the maths, okay? If I am working in the healthcare, genomic core is from the biology. So you should have a strength in those things, and then you can easily get things. And if you have any suggestion or if you have any queries, you can contact your professors. I have given my mail ID. You can contact, you can pursue any professor through the mail, okay? For the internship, that will help you in the future to do a different project with your professor. You can take the guidance from the triple IIT, which is near to you, because maybe IIT Dharwad is far from you, so only the online possibility is there. But a lot of IITs are here, there, nearby this. So you take those few problems from the agriculture, try to solve it so that it get benefited from the agriculture people also, from the society education also, try to, that how we can formulate a problem for the child, okay? Because good tutors are not available. Can we solve as an engineer that few problems, that it should be interactive, it should not be like that one-sided, it should be interesting. So there are a lot of possibility in the AI. You can choose anything. So my good wishes for you, and thank you everyone.
Thank you very much, ma'am. Now it's my honor to introduce our chief guest, Dr. Bharatendu K. Singh, Director of IIIT DM Jabalpur. Dr. Singh is a renowned professor of physics with extensive international experience and a passion for interdisciplinary learning. He has been instrumental in steering IIIT DM Jabalpur towards innovation and global collaborations. With his wealth of experience and visionary leadership, Dr. Singh is an inspiration to us all. Please join me in giving a warm welcome to Dr. Bharatendu Singh, a true champion of transformative education and research. Thundering round of applause for the chief guest of the program, Dr. Bharatendu Singh.
On the dais, Sri R.K. Karsholia ji, Dr. Professor L.K. Patel ji, our esteemed colleague from Dharwad and other institution, I think Dr. Bhadauria. Of the dais, the organizer of this international conference on AI revolution, redefining global progress, esteemed member, faculty members of this institute across the nations, and my beloved dear students. As our esteemed colleague already said about the subject, what you were going through since last 2 days, and I'm pretty sure that during this 2-day deliberation, you must have enjoyed the talk delivered by the esteemed experts across the world. I would not go into the technically on AI because I'm a student of science, natural science. And I'm here just to interact with you. As you know that in this 21st century, we have a very strong privilege that our country is a young country. You know, when I say young country, what does it mean? 2/3 of the population is you people. 65% of the total population is young generations. If you take a look other side of the world, particularly developed world, starting from North America, where United States of America is, Canada is there. Take a look of European nations like Italy, France, Germany. Take a look of Japan. Everyone is an aging nation. There is a reverse. 2/3 population is aged one. And that is why in this 21st century, we believe, Indian believes, that these young minds has to map not only India, across the globe. And when we talk about this mapping of this whole planet with our own skill, the government's focus is on you. And that's why we all are here sensitizing to you that you have to work hard because you are an undergraduate program. You have to get the right skill in this AI era. And that's why we are here to you. As a student of science or as a teacher of yours, what I would request you all, that you have to work on this time management. Everyone is having 24 hours in a day, right? So how you are managing your time? If you look at all of us on the dais, some of our faculty member is of the dais, they have multifaceted job. They have family, they have institutions, they have their parents, grandparents. So we try to manage our 24 hours of time in various aspects, including the teaching and learning, research, innovations. But think about yourself. You have to focus on your study. So you have to maximize your time management. You have to manufacture your time. Make your time in such a way so that every day we get some sort of new knowledge, we can enhance our new knowledge. And that is why you see that the government of India, and particularly our honorable and energetic Prime Minister of the country, Sri Narendra Modi ji, is focusing on this skill development a lot. Every institution has been given a target to go into the hand-holding mode to the another institution and give the right skill to our students. As you know that we are 3 billion economy as of today, right? Top third rank we have achieved. If you look at the world power, you see this. I'm pretty sure that you know that world power is in North America as of today. One nation is leading entire world. But in this era, you see that power is going to shift to the Asian countries. Could be China, could be India, or sometimes we talk about Eurasia. So during this particular segment of period, Indian has to work in a systematic and clever manner so that we can play a greater role towards this planet, right? So in that way, I encourage all of our beloved students to maximize your time. You play with your time management. Can we work 18 hours a day? You know that I never say that I'm a teacher. Still I say I am a student. Why a student? Because I try to learn every day. When I come to this conference, I try to read about this AI. I try to read about machine learning. I try to get this deep learning sort of things. If you go into the history of all this technological development, you will see that whether it's a AI or deep learning, it started by some physics professor who invented this sort of, this methodology of intelligence. And today, after 30 or 40 years of its introducing these fields, now we are going in a big way. So that's why each of you has to maximize your energy efficiency. As I see that this institute, particularly I'm thankful to the Sri Ram group of institution. I see that this institute was even established 4 years before Government of India established IIIT-DM. In 2005, Information Technology Enabled Design and Manufacturing Institute was established in your city near to the airport. But I see that the foundation of this institute was done even 2001 probably, if I'm correct. Okay? So I'm thankful to this Sri Karsholia family who came up with this idea to establish a group of institution in this tiny city of Jabalpur in 25 years back. When you talk about a government institution like where I am, it is easy because government invests a lot of money and life is easy. I can manufacture the G+4 or G+10 buildings. But once it is coming from a social service, like privately, the life is difficult. But somehow, during these 2.5 decades, this group of institutions are catering the need of, as I heard that this campus consists of something like more than 12,000 students. I don't have an idea how IIIT-DM would go in 10 years' time to this number. I cannot think of it. Although we have money, all sort of resources, but there are some challenges. So I would encourage you to particularly focus on your study program. And this is an undergraduate program, I have seen that all engineers, all our kids, after finishing BTech, they wanted to have a placement. In my campus, I always interact with my student and I said that don't go for placement, go for higher education. Can some of you can go to MIT? Some of you can go to Florida Tech or IIT for MTech? Because it's an undergraduate program. You have a basic knowledge in undergraduate program. But if you go to MTech or you go for doctorate, you know that your knowledge is getting multiplied in 2 order or 3 order of magnitude. And then you can do more efficiently, more elegantly, and more constructively towards building your nation. Today, you know that we talk about innovation. In India, most of the institutions are not doing well on innovation. But just last 5 or 7 years, we have taken a pace, and now we are leading in terms of multiplication of innovation or incubations or startups, you know, that always Prime Minister, you know, says that you should not have a job seeker, you should have a job giver, right? So you have to formulate your idea, you have to innovate your idea. Your idea can be converted into innovation, converted into patents, into design, trademark, copyrights, and all sort of things. So I do believe that our Sri Ram group of institutions, student, will also work. And then you see this century is an interdisciplinary century. So computer science student has to interact with electronics engineering has to interact with design or something like that. I can tell you, like in our institute, 3 years back, we don't have much innovation in our campus. When I joined 2.5 years back, we had only 2 patents. Few tens of filed patents. So what we did, we make a group of 5 students, give them a mentor, and these 5 students, 1 student from design, 1 from computer science, 1 from electronics engineering, and 1 from smart manufacturing or mechanical engineering, along with 1 mentor. Give some 25,000 rupees to this group. And now, with this accumulation of number of projects, we give them also the thrust area, like defense project you can do, health sector project you can do, anything you can do. So due to this funding, little funding to the students, they come up with very good idea, and I'm telling you that now, every week in a year we have, how many weeks? 36 weeks. So every week we are filing. So students are coming up with the innovation and it is getting published, it is getting patented. So you should also work on it, come up with your idea, do your innovation. Institution will support you. If institution does not support, Government of India has many these channels where you can get funded for your innovations. So by way of doing this, you can maximize, you know, that your, you can convert your concept into realization, and once your realization comes into innovation, then you can make, sometime later, you can make a product delivery, right? So your idea has to be converted. Our Prime Minister says that idea has to go to the land, to the people, to the society, right? So we have to work on it, and I'm pretty sure that all of our young minds will do sincere efforts, maximize their efficiency and energy. Some of you may go to placement, fine, but always you should innovate your ideas, think out of the box, and by way of doing this, we can build our nation in a constructive manner, and then the nation can have a major role over the planet. So with this word, I would not take much time, and I wish you all the best. And once again, I am thankful to the Sri Ram group of institutions who gave me this chance to interact with our beloved students. So thank you, sir. And thanks to our esteemed colleague. God bless you all. Thank you.
Thank you so much, sir. Ladies and gentlemen, esteemed guests and fellow participants, it's time to express our heartfelt gratitude to everyone who made this international conference a huge success. May I request our respected Group Director, Dr. L.K. Patel, sir, to join me on the stage and present the vote of thanks. Dr. Patel's vision and leadership have been instrumental in shaping this event. Please share your thoughts and gratitude with us. Ladies and gentlemen, let's welcome respected Dr. L.K. Patel, sir.
Honorable Chief Guest of this valediction of the conference, the other honorable members on the dais, the dignitaries from outside, all the principals of the various institutes of the Sri Ram Group, learned faculty members, organizers, guests, if any, and dear students. Today, this is the valediction of IEEE International MPCon 25 conference. As you know, at the end of any program or any event or any conference, there comes a moment when one has to say a few words of appreciation for acknowledging the efforts done by the organizers and other members. So first of all, I avail this opportunity of proposing the vote of thanks. First of all, we start from the inaugural session. The chief guest of inaugural session, Member of Parliament, Honorable Sri Ashish Dubey, when we approached him, our management approached him, he readily accepted to be the chief guest of the inaugural session. So I'm really thankful from your side, from everybody's side, to extend the gratitude to him. The next was our very keynote speaker, with whom we treat as the pride of Jabalpur, Madhya Pradesh, or rather India, Dr. Sudhir Misra, former Director General of DRDO. He worked a lot on the BrahMos missile, and you all know what happened in the Operation Sindoor. So I express my gratitude to him also, though he is a member of, he is alumni of my alma mater, Government Engineering College, Jabalpur. Then our Director, Technical Education, Dr. Viren Kumar, also consented to be present here, and yesterday he was present here. I owe the gratitude to him also. Then we had the various guests from other institutions of the town, with whom we have a very synergetic relationship. We all are working for the quality education to the students in each one institute. Now this program is organized under the aegis of IEEE Madhya Pradesh section. So I am very thankful that the head of the IEEE Madhya Pradesh section, Dr. G.S. Tomar, he was kind enough to make the program and to have the conference here. So the seed of this conference was sown some 10 months back, and during that time, our team has worked a lot. The members of IEEE, they have also cooperated us, particularly in the organization. Our very dynamic director, Dr. Y.M. Dove, he played a vital role. Under his guidance, Dr. Prashant Sharma and Dr. Sapna Chaudhary, they worked throughout. So I am really grateful to all of them. Then other members, whether it is discipline or it is the stage preparation, each and every member has to be contributed. Throughout these 2 days, Dr. Pradeep Dubey has also helped us in maintaining the discipline and in all the management. I will be failing in my duty if I forget the cooperation from the Triple ITDM. Many speakers, especially for the keynote address or for other things, they came to the college and they cooperated. Now, as I have told, that it is a 10 months job. We started the preparation of this program or this conference some 10 months back. So right from there, papers were invited, number of papers came here. The papers, for the papers, the reviewers were set. The reviewers have done a great job. They have gone through the papers. Most of the papers are published, some could not be published. I'm thankful to all authors, those who have submitted the papers. I'm thankful to all reviewers who have gone through and did a tremendous job. Then when we conducted the technical sessions or the sessions, in those sessions also the coordinators were there, the chairman of those sessions were there. So I acknowledge their work also. They have done a lot. Now, it is not only the organizers, but each and every member of Sri Ram Group family contributed in it. Even our students sitting over here or maybe in classes or at other places, each and everyone has cooperated in this. This is a very good signal or a sign to me and to our management. I will be failing in my duty if I do not name, instead of naming, or if I don't say a few words about the efforts of the class 3 and class 4 workers, the account section. And in these 2 days, media also cooperated us. So I think the program or the event, the conference is successful. If there are certain follies or shortcomings, I, being the head of the Sri Ram Group, take the responsibility. Follies are mine, and I will try to improve them in the next event or programs which are to follow. So, once again, I am expressing my gratitude. I'm really indebted to those who have showered their blessings and those who have cooperated us. So, thank you very much.
Thank you so much, sir. Thank you, students. And we request you to kindly be seated. First, our guest will proceed for the lunch, and then we'll proceed. Thank you very much, sir.